turn off your camera.
All right, well, I will share screen. So can everyone see what I'm having right now? Yeah. Okay. All right. So yeah, cool. So what I want to go through today is, like I said, not necessarily for this particular project, but kind of what I would be thinking when I'm designing a robot in CAD, and kind of the things to remember, and kind of the things to note when you're doing particular things. I'll kind of go through some of these slides, but they get a bit boring, so I will soon switch to Fusion 360 and actually start doing CAD, and then try and explain what I'm doing as I'm doing it, and then maybe you'll get some insights from that. But if something doesn't work, or if you want to ask a question, please do shout out. Okay, so 3 main points that if you're gonna take away from this session today is that when you're doing CAD for robotics, and especially making stuff like in real world rather than just some random design, then you have to think how is this design going to be made in the real world. That this is something which is overlooked, and it's kind of difficult as well because you need to also have some level of experience with building stuff. So it's not simply like just think about it and then there's no simple metric, but it's something to always consider. And there's 3 things: the manufacturing of it. So how can I actually make the robot? How can an assembly? How can it put together? And also about the components. So what components I'm going to use and where to buy them and stuff like this. So manufacturing, like you mentioned, first of all, you need to know how am I going to be able to manufacture parts? Is it 3D printing? Is it metal work? Is it literally just like, cutting cardboard? Like there's different ways of manufacturing stuff. And then given that, how is my part going to be able to be manufactured? What's the cost? What's the lead time? Is there is a better way of manufacturing a particular thing? Like these are something to think about. Same as assembly. Assembly is also kind of overlooked because you really get caught up designing something, and then you realize that you make it and you actually make the physical thing, and you realize these 2 things don't fit together because they need to go in a particular order, which kind of conflicts with one another. So that's definitely to keep in mind. It also applies to things like electronics and wiring, because usually when you're CADing, you don't include wires or nuts and bolts. And then in the real world, you put that and then realize, okay, this is actually not going to work. So that's something to keep in mind. And finally, components. Obviously, to get started on your CAD, you need to know what components you'll be using. So that's more of the starting step of CADing a robot. I'll go through a little bit of useful tips and some other, I would say, less like smaller ideas, but also very important. So first thing is fastening. So especially for these robotics CAD projects, you're going to have many components and many parts, and you need to know how to put them together. And there are a few ways of commonly doing this. The first thing is bolting. So using a nut and bolt, put them together. You can also use self-threading, which means you have for example, this for 3D printing in particular, but you make the hole a little bit smaller than the bolt, and then you just kind of like push it into the 3D print. And if it's something that you kind of lightly want to fasten, then it's absolutely fine. You can also use threaded inserts. So some of you guys, well, I guess all of you guys did the Varsity Minibots, and you saw the kit had these kind of brass colored threads inside the 3D print. So this is like a threaded insert, which you kind of melt into the print, and then your 3D print now has some embedded nuts inside, which is really useful. There's also adhesive tapes, but I think the first 3 is, for example, I would be thinking these 3 mainly. Tolerances comes with experience, but it's something to think about, especially when you're printing. Holes will contract usually, and given that you're printing in a particular direction, certain parts will expand or shrink. it's hard to say how exactly it will behave. It's more of an experience guided thing, but it's certainly something to keep in mind. Yeah, same with 3D printing, print direction. How do you change your infill, wall thickness, stuff like this? And other constraints, for example, what is there a maximum weight on the robot? Is there a maximum size limit on the robot? And obviously, these are something that you need to kind of think about during a CADing process. So I've kind of gone through them quickly. It's because I don't want to spend too much time on these conceptual things, but rather show you what I would go through. I'm going to go to doing a kind of starting a CAD project, a very simple one right now, and try to articulate what I'm thinking as I'm doing, kind of using the software. And another important thing to note is that I was kind of in a similar position as everyone here, in the sense that I don't have any formal training of CAD or anything. I just kind of Googled my way around and learned, or like self-taught myself to some extent. So the way I'm explaining or the way I'm using the software is probably not the optimum way of doing things. So take it as one way of doing CAD, not the way of doing CAD. But having said that, let's get on to it. So imagine if you want to make a 2-wheel balancing robot. So the first thing that you always do is you need to have a conceptual idea, like a physical 3D idea in your head of what you're trying to make. Because if you don't have that, you can't start anywhere. So in which case, this is really easy because you just Google 2-wheel self-balancing robot, and then you get this kind of stuff. And then you're like, okay, so this is what I want to make. You have 2 wheels, you have 2 motors on the side, then you have electronics, and you want to put some sensors and let it balance on its own. So cool. We have a good image of what we are trying to do. On a little bit of a tangent, for something like the rescue robot, I don't know if you're familiar with one of the projects for Robotics Society. So can everyone see my CAD right now? Yeah, good. So this is, I'm just going to show you 3 files of the current models. This was me trying to think about how everything's going to fit together. And sometimes, so this is the next step after you do some little drawing on your notebook. So I had a little drawing and okay, well, I need to add dimensions. So I make this simple sketch to see where everything is going to go, have some rough idea where stuff is going to be placed, what the size is going to be. And then you move slightly into a more detailed model. So I start adding a little more detail. So you can see it's slightly more complicated. There's distinct parts and assembly, but this is still very much a conceptual thing. And once I roughly know where everything is going to be and have a better idea of how things are going to look and how things are going to be placed, then you can start putting everything into a more detailed file, which we will actually use to 3D print. For example, right now is this. So that was a big jump, but it's essentially a jump from a concept to something that you can use to start actually making your robot. The design process for this simple case, let's start a new design, for the self-balancing robot is basically the same. You need to know, first of all, what kind of components we'll be using. Because if you don't know the components, if you don't know what motors you're going to use, if you don't know what microcontroller you're going to use, if you don't know what sensors you're going to use, or the size of the robot, then you don't have a starting point. And because there's so many ways of making a particular product or a particular robot, you need to anchor down in one way or another. And usually components is a good way to start. So let's say I wanted to use a particular motor. And let's say I want to use a dynamic cell motor, dynamic cell XL motor. And so the first thing I would do is I would go on GrabCAD. So GrabCAD, if you don't know, is a open source CAD community or CAD like repository, whatever you call it. But basically, you have all these like files you can just get download for free, and then usually what you want to download is inside here. So let's say you want to do dynamic cell motor. By the way, dynamic cell motors are just a particular servo motor. And you can see there are all these kind of files that are available.
Hi, if you want to share your screen, you probably want to move it.
Oh, I'm sorry. Can you see now?
Yeah,
I can't see them.
We can see GrabCAD now.
Yeah, sorry, I was on Fusion and I didn't realize. Please let me know. So yeah, I'm on GrabCAD and I just typed dynamic cell motor and these are some of the results. And you can do the same, for example, if you're doing like Arduino, then yeah, you get a lot of these files and it saves you a lot of time trying to CAD up a very simple part that exists as a component on the market. So I think I wanted to use the XL430 motor. So here, this is, you have some other stuff, but you can see the motor right here. So let's say, okay, let's download this. And so I download this file and I can unzip it. Oh no, it's already there. Good. So I go to Fusion and I can go to the components. So I've already downloaded some stuff, which I will use for this demo. I can do upload and drag this file in here and upload it. So essentially what you're doing is all the components that exist already in reality, 99% of the time, someone's already made it before. So it's probably a better idea to use that rather than make your own just to save time. So how are we doing with time? 15 minutes. Good. So now that we have the motors, let's try to put the motors and all the other components, which I'll kind of go through, in a rough configuration. So we have a kind of a nice idea of where everything is going to be in place. So let's first open the motor. If we open this, we get all of this, but we're only looking for the motor. We don't care about the stuff. We click on the motor, we see it's this component. I'm not going to go too much into how to use Fusion and some of the tips here, and it's a similar kind of idea in SolidWorks. But let's get rid of these guys. So I'm just going to remove them, delete them. So now it's only the motor. Great. So let's save that. Let's also change this name. Once this saves, rename dynamic cell motor. Right. So we have your motor, and let's say we want to use the Raspberry Pi Zero. So I've already downloaded this before this meeting, so you can see this is also someone's made it. Imagine making this yourself; it's going to take infinite time to do this, so that's very good. You also need this component called the Robotis U2D2 if you want to use these motors. This is nothing to do with this CAD; it's just how to use the motor. You might, if you're using a DC motor, for example, in your Varsity Minibots robot, you might be using a H-bridge motor driver, which you guys used. So, these are just other components which you would need to make the robot into reality. I've also kind of made a wheel just before this meeting. This is just a random kind of design of a wheel. It doesn't necessarily need to be like this, but